All right, solving absolute value equations, right? So there's two steps that we have to go through in solving an absolute value equation. Two steps. One, we must isolate the absolute value expression. So if we're solving for an absolute value, we have to get the absolute value by itself, right? Get the expression, isolate it. And then two, we must solve two cases. Okay, and it goes to the whole idea of the piecewise function, right? Remember, absolute values can be expressed as a piecewise function, right? Because at some point they hit 0. And then instead of going negative, they either reflect back up, right? So we looked at straight lines and we said, well, you know, we had this straight line, looked like this, and now we're doing the absolute value of that, so this part here gets reflected up, right? And then, you know, there's an important point happening here. So we're going to solve two cases. All right, so let's get to it. Start with something easy. The absolute value of 2x minus 5 is equal to 9. Okay, so you can probably pretty quickly come up with a value of x that's going to make that true. I mean, we don't have to go into the hundreds or anything. You know, we can say, oh, hey, if x were this, then that would be true, right? But we need something systematic, right? We need a way to solve these. So number one, step one, isolate the absolute value. It's already done, right? The absolute value expression is by itself. Step two, two cases. So we now look at the absolute value function, right? We say the absolute value of 2x minus 5 is equal to, so remember, it's a piecewise function, right? So it's just equal to 2x minus 5 if x, okay, what about x? If x is what? No, okay, so let's go over here, scratch paper. So if 2x minus 5 is greater than or equal to 0, right, then we don't need to do anything, right? The absolute value function doesn't need to do anything to it, right? It just says just take it as it is because it's already positive. Well, when's that going to happen? Well, that'll happen if 2x is greater than or equal to 5 or if x is greater than or equal to 5 halves. So anytime that x is greater than or equal to 5 halves, 2x minus 5 is going to be positive, right? You could try it. So this is like 2.5. So if you throw a 3 in there, 2 times 3 is 6, minus 5 is 1, that's positive. You throw a 5 halves in there, 2 times 5 halves is 5, minus 5 is 0. Okay. But 0, although being the Switzerland of numbers, you know, neither positive nor negative, we're just going to include it with this guy. So if x is greater than or equal to 5 halves, leave it alone. It's going to output a positive number, right? Function 2x minus 5. But if x is less than 5 halves, then this expression will be negative. So how do we make it positive? We take the negative of it, right? If we negate a negative, so if we take the negative of 2x minus 5, then we'll turn it into a positive value, right? So let's just try that. Let's take a number less than 5 halves, like 0. 2 times 0 is 0, minus 5 is negative 5. What's the negative of negative 5? 5, right? So that'll turn it positive, right? So this all goes back many weeks ago, right? Because at this point it is weeks ago, right? When did we? Evaluating absolute value expression, Monday, March 16th, right? That's like 2 weeks ago, right? 2 weeks ago. When we first started looking at absolute values, right? That's when this goes back to. All right, so we have to isolate the absolute value, which in this case is done for us. We now have to do two cases, right? Case number one. 2x minus 5 is equal to 9. So case number one is this. Right? It's just the 2x minus 5. And that's equal to 9. All right, when is that equal to 9? Well, when 2x is equal to 14. And so x is equal to 7. All right, and we can see if we put a 7 in there, 2 times 7 is 14, minus 5 is 9. The absolute value of 9 is 9 works. Okay, we're going to formalize this too, right? We'll do a formal verification. Case number 2. Case 2 is this one here. Do this one. It's the negative of 2x minus 5 is equal to 9. If that's true, then we're going to have a solution, right? So we got a couple ways we can work this out. We can distribute the negative through the brackets, go negative 2x plus 5 equals 9. So I'll do that. I'll show you a couple ways, right? So we can go negative 2x plus 5 is equal to 9. Negative 2x is equal to 9 minus 5, which is 4. And so x is equal to negative 2. Right? Or you can go 2x minus 5. Well, we can get rid of that negative sign, right? Is equal to negative 9. Right? So in that case, what I'm doing is taking the negative, multiplying both sides by a negative, right? So I'm turning the left side positive, turning the right side negative, which means 2x is equal to negative 4, and x is equal to negative 2, right? It can't give you a different answer. It's just a different way of going about it, right? So your choice, okay, whatever you like. You know, just say, hey, let's multiply both sides by a negative, then this becomes 2x minus 5. This side is negative 9. Because think about it, right? If this expression is equal to negative 9, what are we going to do with it? We're going to take its absolute value. What's that going to do? Make it positive, right? So the two cases are really if this is equal to 9 or if this expression is equal to negative 9, right? But this is how we enumerate it, right? This is how we show it, okay? And we've got these things, right? So this tells us if x is bigger than 2.5, and this says x is 7, and 7 is bigger than 2.5, so this should work. As a matter of fact, we know it works, right? Because 2 times 7 is 14, minus 5 is 9. And this says if x is less than 2.5, and then negative 2 is less than 2.5, then this should work, okay? And we can check that, right? So anytime you solve, you have to check, because sometimes we introduce solutions which aren't solutions to the original, right? May not happen. Okay, we're going to do a formal verification though, right? So verify. So if x is equal to 7. All right, so the left side is equal to the absolute value of 2x minus 5. And the right side is equal to 9. When I'm doing a verify, I always go with the original expression, right? Go with the original. Don't go with anything that you've done since then. So this is equal to the absolute value of 2 times 7 minus 5, which is the absolute value of 14 minus 5, which is the absolute value of 9, which is 9. Okay, so that checks. All right, now, even if you don't have to do a formal verification, you should at least be doing a mental check. And verify what if x is equal to negative 2. Okay, so the right side is still 9, and the left side is still the absolute value of 2x minus 5. So that's the absolute value of 2 times negative 2 minus 5. It's the absolute value of negative 4 minus 5, which is the absolute value of negative 9, which is 9, and that checks as well. So both of those are good, right? And they match up with what we set up here, right? Hey, when we're solving case 1, the answer should be bigger than 2.5, right? If we get a solution less than 2.5, then we should think, I should check that, but I don't think it's going to work. And here, the value of x that we get in case 2 should be less than 2.5, right? Or equal to. All right. Questions? You can do this on your calculator as well, right? So get your calculators out. Go to y equals. Your absolute value function is sitting under the math menu under num ABS. If you have an older calculator, it's going to show ABS. If you have a newer calculator, it'll show the bars.
On a test, you want formal verification to work.
If we say and verify, yes. If not, no. All right. Okay. And if it's multiple choice, no. All right, so what do we got? The absolute value of 2x minus 5. 2x minus 5. And what do we want that to be equal to? 9. Graph. All right, here comes the absolute value of 2x minus 5, right? Where's it hitting? 5 halves, right? 2.5. And there's 9. Oh, okay. And second calc intersect. Where do they intersect? Just going to move up there. 1, 2. Don't be surprised. It comes out as -2. Okay. And second calc intersect. And you know what? It's going to be easier to move along the straight line, so I'm just going to move it up, right? So the up-down just moves you from y1 to y2, and then I can just move along the straight line, holding for 3 seconds or less. All right, and 1, 2, 3, 7. Right? Now, seeing as those numbers are integers, you could also look in the table, right? Second table. And you say, all right, so this when x is 7, I've got a 9. And when x is -2, I've got a 9. Okay. Now in this case, you wouldn't really need to graph y2, right? I don't need to see all the 9s. Right? I'm just looking, you know, if I know my answers are integers, then a quick verification in the table is just to plug it in, absolute value of 2x minus 5, and say, okay, when x is -2. And so now we should kind of formalize our solution, right? So what's our solution? Our solution is, let's write that here. X is equal to -2, 7, right? And use brace brackets, not ordered pair, right? So don't put parentheses around that. That would say, hey, this is an ordered pair, which is a point on the coordinate plane, which is not the answer to this question. Right? So it is the values of x when they're 2, or you can write x equals -2 or x equals 7, right? Just some way, right? You should enumerate your solution. You should show that, right? Look, I've solved it. Here it is, right? And they're verified. Okay. Any questions? Too late. It's gone. You had your chance. All right. The absolute value of x minus 2 is equal to 3x plus 1. Okay, what's different this time? Well, we got x's on both sides, right? So this is not so easy. You know, the other one, you could have looked at that and said, hey, if x is 7, I'm going to get 14 minus 5, which is 9. Right? You can't look at this and say, hey, if x, then I got to substitute an x in over there. Okay, so we need to solve this, right? We can do it graphically, and we'll verify this, right? We'll graph it and verify it, but we need to be able to do this algebraically. Step 1, isolate the absolute value. Okay, that's done, right? Absolute value on the left, isolated. Step 2, so now you say, well, there's got to be 2 cases. So what is the absolute value of x minus 2? Well, it's just x minus 2 if x, what about x? X is smaller than 17, larger than a bread box. So when is that positive? As long as x is, yeah, greater than or equal to 2, right? Okay. I don't know. Where'd it go? Pushed it down. All right, so x minus 2 has to be greater than or equal to 0, right? Which means what? I know, it's heavy-duty math here, right? We're going to add 2 to both sides. X is greater than or equal to 2, right? So if x is greater than or equal to 2, then we're going to use x minus 2, right? Any value of x you put in there that's bigger than 2 or equal to 2 is going to give you a positive value, or 0. Okay, and we don't want 0, right? I mean, you make x 0 now, so it's not going to change. All right, and it's equal to 1. Well, we have to take the negative of that if x is less than 2, right? These two kind of pair up, right? So once you figured out this one just comes out with it, right? And it's just saying less than. You don't have to recalculate. So if x were less than 2, like 0, then I'd get 0 minus 2, which is a negative, so I've got to take the negative of a negative to make it positive, right? So we take the negative of this expression, right? And I just write it that exact way, right? The negative of the expression. Right? Don't get fancy. Okay, case 1. Case 1 is x minus 2 is equal to 3x plus 1, right? Case 1 is this guy. Take that expression, the expression of x minus 2, and set it equal to 3x plus 1 and solve. Okay, so solve. What do we get? Take a moment. Solve. It's linear, right? So there's only one answer for x. Seriously. Come on. How long does this take? Really? If you subtract the x, all right, so negative 3 is equal to 2x, so x is negative 3 halves. Right, so I'm going to subtract 1 and move the 1 over there, it becomes negative 3. I'm going to move the x over there, it becomes negative x. 3x minus x is 2x, x is negative 3 halves. Okay. Don't worry, if you get it wrong, it's not going to verify very well. Right? Well, actually, it might. Because now what does case 1 say? It says that x has to be greater than or equal to 2. Is that greater than or equal to 2? No. So this shouldn't work. Okay? Now we'll do a formal verification and show, look, it really doesn't work, but you know, that one shouldn't work. All right, so that shouldn't be a solution. What's case 2? So case 2 says if you take the negative of the expression, you get 3x plus 1. All right, I'm not going to do it both ways this time. So what are we going to do with that negative? Multiply the negative 3, right? I mean, you either... Yeah. So negative x plus 2 is equal to 3x plus 1. So I could go 1 is equal to 4x. So x is 1 over 4. 1/4. Now, case 2 says that x should be less than 2. Is 1/4 less than 2? Yeah, so that should work. Okay? So, let's do a verify. So what do we got? X minus 2 is equal to 3x plus 1. So, left side is equal to the absolute value of x minus 2. Right side is equal to 3x plus 1. Okay, it's the absolute value of negative 3 halves minus 2, which is negative 7 halves. Right? Yeah, I'm just going to go there. And the absolute value of that is 7 halves, right? And the right side is 3 times negative 3 halves plus 1, which is negative 9 halves plus 1, which is negative 7 halves. So they're the same, but this one's negative, right? And the absolute value is always positive, so okay, that doesn't check, right? Which shouldn't come as any surprise because we already kind of suspected it shouldn't check because we said, hey, for case 1, x has to be greater than or equal to. And here, the left side is equal to the absolute value of x minus 2. And the right side is equal to 3x plus 1. So 1/4 minus 2. So that's 1/4 minus 8/4, right? Which is negative 7/4. The absolute value of that is 7 over 4. Okay, and the right side is 3 times 1/4 plus 1, which is 3/4 plus 1, which is 3/4 plus 4/4, or 7/4, so that works. Okay. All nice and algebraic-like, right? Okay, so what does this look like? Let's go back to y equals. What do we got? X minus 2. So can I just delete that? Here, change that to a 2. Come down, let's get rid of that. And what do we want? 3x plus 1. And graph. I'm not going to use the table this time because the table doesn't show values of a quarter. Aha. So there's 1, there's 0s. That could be 1/4, right? Intersect. Yeah, we're pretty close. 1, 2, 3. 0.25. 1/4. Right? And y value is 1.75 if that comes in. So that does verify, right? So that's verifying graphically, right? We checked it out. Okay, so if it doesn't say and verify, you don't have to show, but you do have to show. So ultimately, when you state your, and then we should say something about here about this is extraneous. Okay, so it's not a root, right? Which we suspected because this condition for case 1 said that x should be greater than or equal to 2, right? If this is true, then x is greater than or equal to 2. Okay, questions? Comments? Concerns? Moving on. The absolute value of 5x minus 7. Plus 5 is equal to 1. Okay, what's step 1? Isolate the absolute value, right? So we got to subtract 5 from both sides. Okay, what's that going to give us? Okay, and now what? You said what? Wait. That doesn't make sense because an absolute value must be positive. So the left-hand side is positive, but the right-hand side is negative. So what's the solution? There is no solution. Okay. You cannot get a negative value out of the left-hand side, right? Whatever you put into the absolute value of 5x minus 7 will be made positive, so it can't be equal to -4, right? So looking at that, you can say, I don't even need to do this, right? Because I cannot find a value of x that's going to make this true. We could do the two cases, right? We could say 5x minus 7 equals -4. We could solve that, and we could do the negative of 5x minus 7 equals -4, and we could solve that, but neither of them are going to check. Right? They won't make it. So another way to say that is to say the empty set. That's the notation for an empty set. Okay, so it's set brackets and then a 0 with a slash through, which indicates this is an empty set, right? There's nothing in there. There is no solution set. All right, that was easy, right? Okay, 2 more. Not so easy now. Okay. The absolute value of x minus 5 is equal to x squared minus 8x plus 15. Okay, well, yeah, all right. Now you think about it, I mean, what's the absolute value of x minus 5? Well, I mean, x minus 5, y equals x minus 5 is a straight line with a slope of 1 and a y-intercept of -5, right? And the absolute value of that just means you've taken any part that's below the axis and reflected it up. Okay, and then x squared minus 8x plus 15 is a quadratic. So it's in a sense, it's kind of a linear quadratic, right? Solving a linear quadratic. But we actually have two cases. We have to solve two linear quadratics. So isolate the absolute value. It is. Okay, it's by itself. What is the absolute value of x minus 5? Well, it's just x minus 5 if x what? If x is greater than or equal to 5, right? We're going to subtract something from, we're going to subtract 5 from something, right? Then that something had better be greater than or equal to 5 if I want it to be positive, right? As long as you're bigger than 5 or 5, you're going to get 0 or higher. And what do we say for the second case? Right, and the negative of x minus 5 if x is less than 5, right? So we state the absolute value as a piecewise function, right? There's two different functions. And we have two different cases to solve, right? So case 1, well, that's just x minus 5 is equal to x squared minus 8x plus 15, right? The case where x is greater than or equal to 5, and x minus 5 then will just be a positive. Okay, well, what do we do with that? Well, we're going to have to subtract, so we're going to get x squared. We're going to get minus 9x. We're going to add 5, so that'll be plus 20. And that'll be equal to 0. Okay. Don't mess this up, right? Because this factors, right? It's easy, right? It's x minus 5, x minus 4. If you mess this up, now you're breaking out the quadratic formula, and you're doing a whole pile of work that you shouldn't be doing, because it's wrong anyways, right? So, you know, if that happens to you on a test, like at this point, if this doesn't factor, then I leave it, right? And I go on. Right? I'll come back to it later, but you can bet two things. Before I come back to it, I'm going to solve it graphically so that I know what the solutions are, right? Because I want to come back and just say, are they really going to give us, you know? And if I get an intercept which is 2.7138 or something, yeah, okay, they really did give us that, right? But if I get an intercept that's a nice number, then that says I blew it when I went from there to there. Right? Like I have something that doesn't factor, and I should have something that does factor. Okay, check it over. X squared minus 4 minus 5 is minus 9 plus 20. Right? Okay, what does this say? It says that x is equal to 5 or x is equal to 4. Now what does this say? Well, this says that x is supposed to be greater than or equal to 5. So it says, well, I think 5 is going to be a solution, but I don't think 4 is. Okay. We'll go there in a minute. Got case 2. Case 2 is the negative of x minus 5 is equal to x squared minus 8x plus 15. Okay, we'll just distribute the negative through the left side, right? Get negative x plus 5 is x squared minus 8x plus 15. Okay, add x to both sides, right? So you get x squared, going to add x, so minus 7x, going to subtract 5, plus 10, and that's going to be equal to 0, right? Because there's nothing on the left side now, and then I'm switching sides. That factors, right? It should, yeah. So, you know, again, if you're doing one of these on the test and you're getting something that doesn't factor, before you just start breaking out the quadratic formula and just wandering down the garden path, which is leading you to not much in the way of marks at this point, because you made a mistake with a sign or something, but you're willing to now waste 15 minutes solving it, don't be willing to waste 15 minutes solving it, right? At that point, you just say, I'm just going to leave this, go on, finish some other stuff off, and then come back to it. Right? And I'll show you what I mean by that. Okay, so that's x minus 5 and x minus 2 is equal to 0. You check that, right? X squared minus 2 minus 7. Right? If you're going to make mistakes, it's usually not in the factoring, right? It's in the signs. Right? You got a plus where you should have a minus or vice versa. Okay, so x is equal to 5 or x is equal to 2. So now I suspect, well, this said x equals 5, right? We're getting 5 again. So it's like 5 is going to be a solution. It's just going to be the solution where it's equal to 0, right? If you think about it, you put a 5 in here, you get 0. You put a 5 in here. You could factor this, right? It's x minus 5, x minus 3. You see that 5 will give you 0 here. Or 25 minus 40 is negative 15 plus 15 is 0. So we're going to get a 0 there. When this says x is equal to 4, we don't expect that, right? Because case 1 says x should be greater than. And when this says that x is equal to 2, we do expect that should work. Okay, so here's the question. What are we going to do? Okay, so let's say that you've been solving this. You get to here, and you get some expression here which you can't factor, right? And you've made a mistake, right? So you got something wrong here. So then let's go to the original, right? Let's just go here. So at this point, you've left it. When you come back to it, this is what you do. You turn your calculator on. Apparently it doesn't work. You go to y equals. You put in x minus, absolute value of x minus 5. Okay, you go down here, you clear this out. You put in x squared minus 8x plus 15. X squared minus 8x plus 15. Okay, and you hit graph. All right, so there's x minus 5, right? And then as soon as it hit here, then it became the absolute value of x minus 5. And here's this, and it looks like we have two solutions, right? 1, 2, 3, 4, 5. One of which is at 5. Okay, we can see that. And the other of which appears to be at 2. Okay, well, that tells you a couple of things. One is that whatever you had, this should have led to, right? Like these guys need to lead you to getting answers of 5 and 2. And if you're starting to plug it in the quadratic formula and ending up with like the root of 6, not the root of 23 or something, you know that's not going to get you a 5 or a 2. Okay. Can you see you got 5 and 2? Yeah, you just go into the table, right? And then at this point, we're looking for these guys to be the same, right? 2 and 0, 3, 3 and 3, right? So they're the same. 0 and 0, they're the same. Okay. Otherwise, we can do a second calc, intersect. Come on. And there's x equals 2, and then you can do a second calc intersect again. One, 2, 3. And there's the x equals 5, right? Okay, so you solve that. And because we need practice, we're going to verify all 4 of these answers, right? So we got the absolute value, so the left side is equal to the absolute value of x minus 5, and the right side is equal to x squared minus 8x plus 15, which is the absolute value of 5 minus 5, which is the absolute value of 0, which is 0. That's 25 minus 40 plus 15. Okay, so when x is 5, that checks. X squared minus 8x plus 15. And we're going to put a 4 in here. Now what you're going to find is this side is going to come out to negative 1, right? It's still going to be a 1. Okay, it's going to be a negative 1, right? Because that's why that solved with that. It gave you a negative 1 there. Okay, this is going to give you, so 16 minus 32 plus 15, which is negative 1, and then we reject that, right? And the last thing we have to check is So it's the absolute value of 2 minus 5, which is negative 3, and the absolute value of negative 3 is 3. And this is equal to 2 squared minus 8 times 2 plus 15, which is 4 minus 16 plus 15, which is 3, and that checks. Okay? So, formal checks all around, informal checks using the calculator. Again, we're not going to ask you to verify like 20 of these on a test, right? Maybe one, maybe none, right? But, oh, and we should state our solution, right? So our solution is x is equal to 2 or 5, right? So the solution set, using set notation, the set consists of 2 comma 5, not parentheses, right? That would make it an ordered pair. Right? Or you could just write x equals 2 or x equals 5, and you should cross that one off. Right? And maybe you just verified this mentally, right? Or maybe you just looked up and said, wait, but case 1 says it's got to be greater than or equal to 5, so, 4, I don't think that's going to do it, right? And then you just substitute it in, and, or you graphed it, or whatever. Okay, one more. The absolute value of a quadratic. Okay, so if you think about that, what does that mean? If you think about graphically, what's the absolute value of a quadratic look like? Right, here's this quadratic, and we know it opens up because it's got a positive x squared, and so it's going to kind of come down, and then there's going to be a hump coming up, right? Because the lower portion will have been reflected, so it's going to come down, and then have that little hump, and then go up again. Which makes it a little more difficult to do our cases, right? Okay, isolate the absolute value. Done. What does the absolute value mean? Well, there's two cases, right? It's going to be x squared plus x minus 9 if x has some characteristics which I don't know, because that actually doesn't factor, right? So I can't easily find the roots. Right, you have to use quadratic formula, and it would be like, what's b squared minus 4ac1 minus like root 37 or something? Yeah, so we're not doing that. So you think about, here's what we have. I've got this x squared, I've got this. Okay, now we're doing the absolute value. Okay, and we're actually going to ask you to sketch one of these, right? One or two, going to give you a graph and say on the graph sketch the absolute value function and darken it in, right? Or use a different color or highlight or something. Okay, especially on this part, right? Because it's on both. Okay, this part not so much, and this part, yeah, not really, because you're drawing that. That's new, right? That's clean drawing. But make it obvious, right? This, I think, is pretty obvious. Hey, that's the absolute value of the original thing you started with. But I don't know where these guys are, right? So I do know that if x were greater than this, it was positive, and if x were less than this, it was positive. But I don't know what those are. Okay, and I know that if it's between here and here, that the original one was negative, so we need the negative of this, and too difficult. Yeah, too hard. Très difficile. Right? Like, I don't know. Okay, so what are we going to do? This time then, what that means is we're going to solve it, and then we have to do verifies, right? Because we can't look at the case and say, oh yeah, right? That's greater than or equal to 5, so that should be true. Okay, all right. So what do we do? Well, we got to solve, again, right? Case 1. Case 1 is this, right? X squared plus x minus 9 is equal to 3. Everybody with me on this, right? Okay, so we define the absolute value as two cases. We don't really know where the x's are, right? If x is whatever, okay? So we're just going to say, hey, I can't do that part of it. Okay, so we're going to subtract 3 from both sides. And we're going to say, hey, that factors, right? Because really, What are they trying to test here? Right. Not trying to test if you can use the quadratic formula. Not on this question. All right, so I got an x plus 4 and an x minus 3. So that's x squared minus 3 plus 4 is plus 1 minus 12. All right, it's all good. So x is equal to negative 4, or x is equal to 3. Okay, and these, we are actually going to have to verify them all. We don't know. And case 2. The negative of x squared plus x minus 9 is equal to 3. So in this case, instead of distributing the negative through, what should I do? Multiply both sides by negative 1, right? Just make this positive and make that negative, right? Because as long as, if this works out to negative 3, when I take its absolute value, I'm going to get 3. And this will be easier to do, right? We're just going to add 3. So x squared plus x minus 6 is equal to 0. It's like, who chose these numbers, right? You get 2 of them and they both actually factor. That's pretty cool. X squared, so that's what? X plus 3 and x minus 2. So x is equal to negative 3. Check that. X squared, yeah. Or x is equal to 2. So there are 4 possible solutions, right? All right. So I'm going to do this graphically, right? Because, yeah. So all I need to be able to do now is I want to state, right, x is equal to the set consisting of, and at this point it's just important that I, all right, what do we got here? So absolute value of, let's just clear everything. Okay, what was it? X squared plus x minus 9. X squared plus x minus 9. And this is equal to, right-hand side is 3. So we know what that looks like, right? Because we sketched it. So here it comes. Oh, and there it goes. And then there it goes. Okay, and 3. Oh, how many solutions do we have? 4. So they must all be solutions then, right? So 1, so what do we say? Negative 3. So 1, 2, 3, negative 3, yeah. Negative 4, yeah. Positive 2, yeah. Positive 3, yeah. Okay, so it's all the solutions. Negative 4, negative 3, positive 2, positive 3. Negative 4, negative 3, positive 2, positive 3. Okay, you can look in the table to verify that because they are all nice integers, right? So where is it 3? Negative 4, it's a 3. Negative 3, it's a 3. Positive 2, it's a 3. Positive 3, it's a 3. One other way you could have solved this graphically. And that is you could take this, so instead of looking for where this is equal to 3, you can subtract 3 from both sides, and then you're looking for the zeros, right? So just rearrange the equation so it becomes the absolute value of, right, minus 3 is equal to 0. So you're just going back to here and just saying, hey, that's the same as the absolute value of x squared plus x minus 9 minus 3 is equal to 0. Okay. Now, I wouldn't want to solve this algebraically, right? I'd have to go back to here and then do what we did, right? Otherwise, we can't really solve that. But for doing it graphically, that kind of makes sense, and then I'm just looking for the zeros. Okay, and I graph that, and you can do intersects, because I graphed y2 as 0. So I can do intersects, which are easier than zeros, and we'll just do one of them. 1, 2, 3, and there's the intersection. Okay, questions? Right. But you do have to verify, especially in this case, you have to verify, right? We have no other way of doing this. We can't look at the cases and say, oh, the case 1 says that x has to be this, and it's not, so, okay, so we do have to do verification. All right, so make sure you do some verifications out just for practice, right? Just so that you at least tried it a few times and it won't be sort of, I get to the test and I sit down and start and I just like, oh, I can't remember how to do an algebraic verification. Okay. Which, you might not need to. But keep in mind, there will be extraneous roots, and if you put them in as part of the solution, then you're going to lose marks, right? Or the bridge is going to fall down, which is the, I don't know which is the worst consequence right now. It's probably just losing marks. So I lose marks.